So again, a fun fact. So the second presentation is actually done in Reveal.js, if you know it. So it's a VS Code extension, and Reveal.js is just a simple, show it here. This is what the slides look like. So it's basically just a markdown, and it's a very simple, similar to what Jupyter Notebook slides are using. But what it does is that you can really focus just on the content of the presentation and not deal with the styles. But the style of the Reveal.js is very, very cool, as you will see now. So let's start with the presentation. So here, I will talk about FFMPEG. I will not attempt to pronounce what this all means. You can do it for yourself, but it's basically magic related stuff to all video and images and audio and stuff like that. But before we move on with the content, just a quick word from the company. So as I mentioned before, I'm working for Synergize, and we are hiring. If you're interested in this kind of stuff that I presented in the previous presentation regarding the GraphViz area monitoring project, or even in other stuff like dealing with fun stuff like GraphViz and FFmpeg itself, be sure to apply. We are looking for several. We have several open positions, but we're not. It's not limited to these. Okay, but yeah, let's go on and get ready to be overwhelmed with FFmpeg. By the words of the first hit on Google on FFmpeg, FFmpeg is the leading multimedia software for doing stuff with pretty much everything that humans created. What that means is, we'll show later. So just a quick word about the tool itself. The first release was 20 years ago, but the last stable release was like 7 months ago. So you can see that it's quite an important package and widely used for its age. It's free and open source, similar as GraphViz, dealing with video, audio, images, any mainstream media stream types. At its core, it's a command line interface tool, but it has a lot of bindings and binding tools, for example, including Python, which we will also be focusing on, but in the second part of this presentation. But there's a proof that it's widely used. It's used by VLC, Kodi. So if you're playing with Raspberry Pis, you might be familiar with Kodi. Otherwise, Blender, YouTube, Google Chrome, all big names. Okay, so how it is used? Mostly for, I guess in majority for basic editing, but professionally also for post-production effects, format transcoding, or checking if the videos are up to some standards compliance. All of this boring stuff, but what we will use it is much cooler, so creating nice GIFs and videos. Okay, some of you might have cringed here. If you prefer to pronounce it GIF instead of GIF, then it's your problem. This is my presentation and my rules, and this is what this is not how linguistics work. So I will be using GIF. Okay, similarly as before, enough about the tool itself. Let's look at the meat of the presentation and check it via some specific examples. So we have a video on our YouTube channel, which looks like this. And let's say that I would be interested in the specific video part of the video from this 16-second up to, I don't know, 22. So the satellite is moving away from us and we are orbiting around the Earth. And I would like to cut out this specific portion of the video. I can do this using FFmpeg, shocker. So I downloaded the video. Full video length is 5.5 minutes, 65 megabytes. And in order to cut the video from the 16-second to the 22nd, you can use this command line interface line here. So FFmpeg, input video, start timestamp 16 seconds, to timestamp 22 seconds, output video. It's simple as that. And you can also use just the seconds here, or you can even use just a -t for duration. So 22 minus 16, I believe, is 6. If you just put -t 6 seconds. So this way you get the cut video, which is shown here. So it should loop if we wait for 6 seconds. It looped. So this is the portion of the video. So how to now convert it to GIF? It's very simple. It's most basic command. Again, input video. So now the short video that the input video, cut it, and then just output with the format.gif. This is simple as that. Or you can just use the video that we cut short in the previous slide and just convert it to GIF. And we get something like this. So I'm not sure how well you're able to see this videos. I hope it's at least moving, but compared to the previous cut video, if you look here, you might see some weird texture effects on the GIF itself. So this is the problem of a GIF that we will also be looking into. So yeah, you will see that. So as you see, making GIFs is super easy, but in order to make something that's quite high quality, that's the hard part. So to name a few issues, including the ones that you saw, we have weird effects present, mesh-like or grid-like texture on the GIF. Then we have the fact that GIFs are limited to 256 colors. So you have an 8-bit color limit, and GIFs in itself are not so efficient anymore. We have a lot of other formats or encodings, a lot of other formats like HTML5 or WebM, which are much more easier on the disk size. In this case, if we have a video of 1 megabyte, it can be as large as 30 megabytes or more. So it can produce large files, which are not something we might be interested in. But still, GIFs are convenient, and let's see how to make our life easier by finding some possible solutions. So not to throw GIFs away entirely, but to see if there's some compromise that we can use. So one way is the obvious one, or the cheap one, is to optimize the size. So you can scale down the size if you don't need it, or decrease the frame rate of the GIF. So these are cheap options. Then you can apply some color optimization to fix the color issues or to improve how colors are used. And lastly, to use compression to decrease the size of the GIF on the disk itself. So this, you might think these are relatively obvious, and probably they are, but just wanted to explain a bit more about this. So here is an example of resizing a GIF. So it's done using filters. These filters are a very powerful collection of tools in FFMPEG. If you check this link here, you will again be overwhelmed, as I promised at the beginning. But just to name a few, for example, FPS, it's used for manipulating the frame rate of the videos or the GIFs, and scale for resizing. So in this first line here, after inputting the video, you can select a specific value for the frame rate and specific value for the scale. In this case here, it's dividing the width and the height of the video by 2. And what you can also do is put -1, which controls only one dimension, and then the other is kept at the same aspect ratio. So stuff like this can be useful. And just so you can see, in the end, we have about 4 times smaller video as before by simply decreasing the dimensions by 2 in on each axis. Then the other thing, following the famous words of Missy Elliott, you can flip and reverse the video using H-flip, V-flip, or reverse to do it in each direction separately. So it's obvious that Missy Elliott was at least a basic user of FFmpeg. This is what it looks like when it's flipped in both directions and reversed. If you don't remember, previously the satellite was moving away from us on the other side and flipped vertically. The second part is the color optimization. So I mentioned that we have an 8-bit color limit. So how do GIFs actually reduce this usage of colors? It's done via something called dithering, and this is actually the process of using less colors and creating the illusion that more colors are present. On the image below, you can see it consists of only 2 colors, so black and white, but the final illusion is that this is a grayscale image, ranging from white to black in a gradual scale. So this is dithering, and you can see the same kind of effect of this mesh-like texture that I have shown before in the beginning. So this is the way GIFs reduce the colors. And by default, FFmpeg uses this generic all-purpose color palette. And if you recall our video, we don't see any pink or green or purple or yellow or stuff like that. Just dark, gray, blue, white, stuff like that. And it's possible to take this into our, to turn this into our favor. So in order to do that, we again use these filters, and there are 2 filters that exist for this specific purpose: palettegen and paletteuse. The first one is used to generate the palette, the color palette, and the second one to use it. At the same time, the first one is a simple filter, while the other one is a complex one, where simple filter means that it has 1 input and then 1 output, and complex that it has multiple of said inputs and outputs. So how to do this? We do it in 2 steps. First one is to generate the custom palette using palettegen, 1 input and the palette is the output. And then the second one, paletteuse, uses 2 inputs, which is the video itself and the palette that we just created, and creates a color optimized GIF. So this is it, yeah. This is the new palette. This is what it looks like. And the final GIF is now also larger because all of the 256 colors are now actually used. Before, only a subset of them was being used. And this is the final output. So if we zoom in, we see that there is no we don't see any, or we don't see issues like we did before, not in the same amount. There's still some visible, but much less than before. So bonus content, another filter that I wanted to mention is streams. So there is this filter called split, which splits or duplicates your stream into 2 parts. So you can use it to create 2 cases of the input stream, called S0 and an S1 in this case. And then S0 is used with palettegen to create the palette P. And then the second line uses both S1, which is the copied stream, and the palette P in paletteuse to do it in a single command. So no need to do it in 2 steps anymore. Yeah, okay, so this we're kind of halfway. And if you're like me, you're very sick of a command line interface. As I mentioned before, there are Python bindings, and let's look at those as well. So there exist Python bindings for FFmpeg. The name is straightforward, as you can see. And if you have the command line interface like we have on the top example, what this looks like in Python, you can see in the below example. So you define the video using FFmpeg input. You define the palette using the video, calling the filter palettegen on video, and then again applying this 2 inputs here on paletteuse and producing an output. So it depends on what kind of person you are. I don't know. Maybe you prefer this, maybe you prefer this. Personally, this is quicker, but this is, I think this is more intuitive. So you can do either. But the fun fact is that, for example, in this particular case, FFMPEG Python bindings use GraphViz in the background, and you can also plot what this process looks like. So this is exactly the same thing as we did before. So using the input, split it into streams. One stream is used to create the palette, and both of them are used. So the palette is applied, and then we produce the final output. Okay, this is a simple example as we did in the previous presentation. Let's look at a more serious example now. So this is a concrete project that I had. Yeah, just to show you how I created this animation. So I prepared mosaic images of Australia's vegetation for the whole year of 2020, or I think it was 2019, doesn't matter. So there are 37 of these images throughout the year, one in approximately every 10 days. So the more it's green, the greater the vegetation, and the less vice versa. So we have 37 of these images. Then the next input is a bunch of these timestamps in a visual format. So this has 12 timestamps from January to December, and we have 2 more. I'll mention why later. This is what it looks like, but the important thing is it's 12 of those. And then we have a single image of the color bar of what this vegetation index represents, or the values that it represents. And what is our goal? So we want to make a single fluid high quality animation. And in order to do that, we need to take into account appropriate spatial scaling of all of this input. We have to take into account the correct spatial positioning. We have to make all of these frame rates have to be in sync. So we have to find the compatible values and somehow put them all on the same frame rate. And in the end, we can also apply the color optimization, since we now know how to do. So let's do it. We have the 3 inputs. So the first is called video, but it could be the time lapse. Here we do it like I shown before. So the first input, the second input, the third input, and the first 2, if you notice, have this frame rate option. In the first case, we want to squeeze 73 images into 3 seconds, and the second one 12 into 3 seconds. So our final video will be 3 seconds long. And the second one is the scale. Here are some magic numbers which I have ready from before. So you just basically have to do some trial and error in order to get the correct values. And lastly is the timestamps, since they are only 12 as opposed to 37 of the timestamps of the time lapse of the video input. I wanted to do some motion interpolation so that the transitions are a bit smoother. And in order to do the motion interpolation, to have it cyclically looped, I had to add the 2 additional timestamps, which are basically just copies of the first 2. So this is just a side note, but it's not that important. Then when we have all these inputs ready, we need to overlay them one over the other. So we start in this line here. We take the timestamp and overlay it over the video in the top left corner. And then this itself is the input for the next overlay, where we overlay the color bar over the thing that we just created in the bottom left. Then we do some padding of the white just to have some extra border on all sides. And we use split in order to prepare it for stream duplication. Now, the next step is to do the optimization of the color palette, which you're already familiar with. So I won't repeat it here. In the end, it looks like this. So all of the inputs here, overlays, padding, creating the palettes, using the palette, and creating the output. So relatively simple when you put it like this, and easier to work with in the Python bindings, in my honest opinion. Okay, and this is the final output. So you can see that everything is in sync. You can see the smoother transitions in the, I hope you can see that, in the timestamps. And yeah, this is it. And I would say that it's a high quality output. Okay, so I think this concludes the just optimization parts. A few words about the compression of the GIFs. So again, it could be just a cheap trick in order to optimize the GIF usage. But what to do in these cases? So option A is copy, take your GIF, go to easygif.com, upload it, transform it, then download it. But we don't like this solution. So what we will do is a compromise. So we won't build it from scratch, but we will take the path in between. We will go to easygif.com, see what they use, see that they use gifsicle or gifsicle, download it, install it, and use it. So basically, just a quick word about the gifsicle. It's a tool on its own. It does a lot of the same things that FFmpeg does. We will not use it for those specific things. We will just use it for its advanced compression algorithms. So what does this mean? So it can shrink the color maps, and it can store only the changed portion of each frame in the GIF. So this might not seem familiar to you, so let's look at the concrete example. Here we have a GIF of Bugs Bunny jumping on the spot or running on the spot. You can see that Bugs Bunny itself is moving, but the rest of the GIF is more or less still. So when gifsicle would compress this in this way, that it would just save the things that didn't change. No, sorry, it will just save the things that did change, and the other things, since they remain the same, there's no need to duplicate the information that's hidden in the GIF. So this is one way how to compress it. And for example, if you look at the uncompressed on the left and the compressed on the right, there's a significant disk size reduction, but the quality of the GIFs itself is it's not noticeable, I would say. So that's it about the GIFs. Just a quick word about the video outputs and working with the video outputs. So as mentioned before, there is no color limit. You have smaller file sizes, better frame compression, and so on. So in a sense, it sounds better, but in order to really get high quality videos, you have to tweak it a lot. And in cases like this, Stack Overflow is your friend when working with stuff like this. But just some few mentions of good practices. So usually when saving to a video output, you have to define a video encoder. So these are codecs, as you might know them. You have to define this constant rate factor, which is a number that defines a trade-off between compression and quality related to the video encoder defined above. And then lastly, you also have to set some pixel format, because pixels in itself are just numbers, and you need to tell them what color they represent by defining a color space for them. And just a quick example on the video side. So here we have 3 different videos with 3 different constant rate factors. So different points on the trade-off between compression and quality. On the left is one extreme with large compression and low quality. On the right, it's vice versa. And you can see that the middle would be somewhere optimal, and the orders, so that the changes, the differences between the values of the disk size are orders of magnitude apart. And just so you can see that it pays to put some thought into how to do this. Okay, so this is it. I hope it wasn't not enough about Python, and hopefully you found it interesting as well. Questions?
Okay, thank you very much, Matic. This was very interesting. I used to work a lot with video editing, and I've never thought that you could automate it up to this point. I think you already answered Pustian's question. His question was, when you cut video, what codec and resolution is used?
So just to append to this, yeah. So actually, at the first, we were working with GIFs. So in GIFs, this wasn't related. But yeah, in the video part, as was mentioned, so I think I will just follow these good practices here.
Okay, so one more question from Bostian. How can we achieve that when a video is copied into a directory, it is automatically converted to a certain preset, like format, I think he meant MP4 or
I'm not sure I understand the question, because you have to save the format yourself. For example, in this FFmpeg, you define the format, you define the codecs and everything, and this is then the output. And this is already in the directory.
Okay. I think he's asking about how to automate the conversion of files as soon as it hits one folder. But I think that's a separate issue. It's not FFmpeg related, but maybe like a system administrator. I would use AWS, but
perhaps so when you I think now I understand. So when you copy a video into a directory, you would then need just some automatic job that is spawned that inputs, so takes this where the FFmpeg takes this video and converts it to the output of your specifics. I would say it's something like this.
Okay, so how do you work with the audio? If we have a video with audio, can we, is there like a really simple way to do it, or do we have to kind of treat them separately? Or is like audio just one of the properties of the video from a point of view of the library?
Yeah, good question. In my experience, I haven't really dealt with audio, but as far as I know, the library, audio and video are just two sides of the same coin, and you just you have some tools or filters which are common between them, and some that are specific to video or audio. But it's in the same way. Yeah, we work with them in the same way.
Yeah. Okay. So
it's just another stream.
Yeah. Just like we have with Premiere and all the software. That's how I imagine this, kind of just like an automated way of doing what we're doing in Premiere or iMovie or whatever you may be using.
Mm-hmm.